In an engine governor of the prototype, the upper and lower arms are 200 millimeter and 250 millimeter respectively. Right? So the length of upper arm and the length of lower arms are given and pivoted on the axis of rotation, right? But the pivot is on the axis of rotation. The mass of the central load is 15 kilogram, right? So the mass of the central load is 15 kilogram. The mass of each ball is 2 kilogram, right? And mass of each this ball is 2 kilogram. And friction of the sleeve together with the resistance of the operating gear is equal to a load of 25 Newton at the sleeve, right? So due to the friction and other loads, the operating gear, the load by operating gear, the total disturbing force is 25 Newton, right? Friction plus the resistance of the operating gear altogether will giving us 25 Newton at the sleeve, right? So now we have to think, if the governor is moving upwards, the friction will act downwards. If the governor is moving downwards, the friction will act upwards. Okay. If the limiting inclinations of the upper arms to the vertical are 30 degree and 40 degree, right? So now the limiting inclination is given, right? So this can go from 30 to 40, right? The limiting inclination. If the limiting inclination of the upper arm to the vertical are 30 and 40, taking friction into account, range of speed of the governor, right? So based on these conditions, we have to find the range of governor. So there is friction, the maximum range is 30 to 40 degree, and now we have to find the range based on these conditions. Okay. So now we'll write the data first. Okay. So BP upper arm, right? Upper arm is 200 millimeter, right? BP is 200. BD lower arm, that is 250. Okay. Then the mass of the ball 2 kilogram, right? Then the mass of this load, central load, that is 15 kilogram, right? Capital M is 15 kilograms, small m is 2 kilogram. Okay. The force by friction is 25 Newton. Okay. Alpha 1, that is 30, alpha 2 is 40, right? So alpha 1 is the minimum limit and alpha 2 is the maximum limit, that is 30 and 40. Okay. So these are the given data. So now we have to find the maximum and minimum range, right? Why the question asked is to find the range. If we want to find the range, we have to find the maximum and minimum speeds, right? So first we'll find the minimum speed. Okay. So we'll consider n1 as the minimum speed. Okay. N1 as the minimum speed and n2 as the maximum speed. Okay. From this figure, we can see R1, right? So n1 is the minimum speed, then R1 is the radius of minimum speed is equal to BG, right? R1 is equal to BG. So this BG is equal to BP sine theta, right? BG sine alpha here, right? BG sine alpha 1. BG, not BG, sorry, BG is equal to BP sine alpha 1. So the length of BP we know 200, right? So that is 0.2 meter into sine of 30, right? Sine of 30 is half, that is 0.5. Okay. So when you solve it, R1 is coming as 0.1 meter. Okay. Now we found the distance of BG, that is R1. Okay. If we know the R1, we can calculate the H1. How? By Pythagorean relation. We know this length, we know this length, so we can find this length. Okay. So based on that, we'll try to find the H1. H1 is equal to BP cos theta. Okay. So H1 BP cos theta. So we know BP is 200, cos 30 is 0.86. So 0.2 into 0.86, that is 0.1732 meter. Okay. So now we know this height also, right? So this is the height of the governor. Okay. So this is the height of the governor and this is the radius. All right. Now we have to find the DG. Okay. DG. So similar way, we can find DG is equal to BD squared, BD squared minus BG squared. Okay. So BD, that is 250 whole squared, minus BG, that is 0.1 that is 100 whole square. So at last we will get dg equal to 0.23 meter, right? So this is 0.23 meter. dg is equal to 0.23 meter, and therefore tan beta is equal to, right, tan beta we know bg upon dg, that is 0.1 upon 0.23. So the answer is 0.4348. So tan beta 1 is equal to 0.4348. Okay, we'll have it. Tan alpha, right, tan alpha 1 equal to tan 30, that is 0.5774, right? So this is 5774 tan alpha 1. Q1 is equal to tan beta upon tan alpha, right? So we have taken Q as tan beta upon tan alpha. So based on these values, tan beta upon tan alpha, that is 0.4348 upon 0.5774, that is equal to 0.753, right? So Q is equal to 0.753. We taking it as Q1 because it is at minimum speed. So here angle, radius, height, everything as 1, R1, H1, tan beta 1, tan alpha 1, Q1 all as 1 because this is minimum speed, right? We take N1 as the minimum speed, right? So similar thing we have to do for the maximum speed also, right? Before doing that, we will now apply it in the formula. We know that when the sleeve move downwards, the frictional force F act upwards, right? So minimum speed mean we know that ball tend to move inwards, which means the sleeve tend to move downwards. So in that case, the force will act upwards, right? Now we'll now put it in the equation. So the minimum speed is given by n1 whole square is equal to, right, now we are applying it in the equation, mg plus capital Mg by 2 minus F, right? Why? Mg is acting downwards, but the force is trying to act upwards, therefore minus F into 1 plus Q1, right? 1 plus Q, now we have found 0.753, okay? So 1 plus 0.753 upon Mg, okay? And in the numericals, if it is not given, we can take G as 9.81, right? So in this equation, we will replace the given as well as the found data. Okay, M, that is 2 kilogram, G 9.81 plus capital M, it was given 15 into G 9.81 minus frictional force F, that is 24. Okay, it is 25, it is given in the question, but they have replaced it with 24, so we'll consider it as 24. Okay, upon 2 into 1 plus Q, we have found it is 0.753, okay, 0.753 upon mg, that is 2, m is small m is 2 into g 9.81 into 895 upon h1, small h1 we have already found how much, 0.1732, right, 0.1732. So when you solve it, n1 squared is 33,596, which means n is equal to 183.3 rpm. Okay, so this is for minimum condition, right? This is for minimum condition. Now we are going to find the for the maximum condition. Okay, so we will now draw or consider, right? So this for the maximum position. So we'll replace all this r, h, everything with 2, right? So r2, h2, tan beta 2, tan alpha 2, q2, right? So in this condition, we'll now find one by one, right? So first we will find R2, R2. So R2, we know R2 is BG, right? BG, that is BP sine alpha, right? BP sine alpha 2, right? So which means BP into sine 40. Why? Because here the maximum condition, that is 40 degree, right? So the maximum condition, it is 40 degree. So now we are going to use 40 degree here, right? So this is alpha 2. I am trying to write alpha, okay? and here this would be beta. Okay, so now R2, that is this length, equal to BG, right? BG is equal to BP sin alpha, right? H2 is BP cos alpha, right? So we know BG is BP sin alpha and PG is BP cos alpha. So R2 is equal to 200 into sin 40, right? So 200 millimeters. So when we convert it 0.2 meter, 0.2 meter into sin 40, that is 0.643. When I solve it, it is 0.1268 meter. Okay. Then height of the governor, that is H2. H2 is BP cos alpha, right? BP cos alpha. So BP we know 0.2 into cos 40, right? So H2 is equal to BP cos 40, BP 0.2 into cos 40, 0.766. When you solve it, you will have 0.1532 meter. Okay. So now we have R2 and now we have H2. All right. And now we are going to find the value of Q. For that, we need tan Q. For that, we need this length also. Okay. So how do we find this length? DG. We need DG, right? We need DG. Why? Because we need to find tan beta, right? So if we want to find tan beta, we need to find BG upon DG. We already know BG, but we don't know DG, so we are going to find DG. How do we find DG? DG whole thing squared is equal to DB whole thing squared minus BG whole thing squared, right? So DG is equal to under root of BD squared minus BG squared. So BD already known, it is 0.25, right? So DG is equal to BD squared minus DG squared under root. So that is under root of 0.25 whole squared minus BG. BG we have already found, that is R2, that is equal to 0.1268 meter, right? 0.1268 meter whole squared, right? So DG, the length of DG is 0.2154 meter, right? So now we have found the length of this DG also, right? So based on this, we can find tan beta. Already with the data, we can find tan alpha, so we can find Q, right? So tan beta is equal to, tan beta 2 is equal to BG upon DG. So BG, it is R2, that is 0.1268 meter upon DG now we have found 0.2154 meter, right? So tan beta 2 is equal to 0.59, okay? And tan alpha 2, right? Tan alpha 2, that is tan 40, which is equal to 0.839, okay? And we know Q is equal to tan beta upon tan alpha, right? So Q2 is equal to tan beta 2 upon tan alpha 2. Tan beta 2 we have found 0.59 upon tan alpha 2 0.839. When you solve it, you will have 0.703, right? So this is the value of Q, right? So now to replace in the equation, we know Q also, right? We already other data are given. Now we have to find Q that we already have found, right? So now we can apply in the equation. So what is our equation? N2, right? So now we are going to go for N2, that is maximum speed. Small mg plus capital small mg plus small mg plus f by 2 into 1 plus q2 upon mg into 895 by h2, right? So now we need to consider the friction. Where to apply this friction? Which side? Which direction? We know that when the sleeve move upwards, the frictional force acts downwards, and the maximum speed is given by this formula. Why? When the speed increases, we know the sleeve move upwards. If the sleeve move upwards, the frictional force will act downwards. So therefore, F is positive. Why? Weight mg, mass is also acting downwards. Frictional force F is also acting downwards. That's why it is positive, right? So when you substitute all these values in this equation, you will have N2 squared is equal to M, that is mass of the ball, that is 2 kilogram, G 9.81 plus small m, this should be capital M, okay? That is the mass of the central length, right? So mass of this central length, that is mg, capital M. So capital M is 15 into G 9.81, okay, plus 24. Okay, so I think in the question it should be 24, right? So we'll change it. So this is 24 Newton. Okay. And also here it should be capital M. Okay. According to our formula, this should be capital M into G. Okay. So capital M is 15 into G, that is 9.81 by 2 plus this F is 24, that is frictional force. And we take it as plus. Why? Because mass is acting downwards. This frictional force is acting also downwards. Why? Because the sleeve is trying to move upwards with the increase of the weight, increase of the speed, right? And that's why this is also positive. Into 1 plus Q. 1 plus Q we have already found, that is 0.703, right? Q2 is 0.703. So that is 0.703 upon mg, m 2 kilograms, mod m2 into g 9.81 into 895 upon h2. H2 we have found, it is 0.1532 meter, right? That is 0.1532 meter, right? When you solve it, you will have 49,236. N2 square is equal to 49,236. Okay. So when you take N2, that is 222 RPM, that is 222 RPM. Okay. So at the minimum speed, the RPM is 183.3. At maximum speed, that is 222 RPM. So now we have to find the range. We know how to find the range. The maximum minus minimum, that is 222 minus 183.3, which will give you 38.7 RPM, right? So this is the answer for the question. What's the question? Taking into action the force in the friction, find the range of speed of the governor, right? So your final answer is 38.7 RPM.